So in this video I'm going to talk about how we go about raising the imaginary number up to higher powers. If this lesson is going to have any hope of making sense, there's some things that I'm going to need you to know. So there's really two major things. The first one, from the previous video, you need to know that the square root of -1 is I. Second thing you need to know is that the first three powers of I we can work with. In the previous video we talked about why I squared is equal to -1, why I cubed is equal to -I, and why I to the fourth is equal to 1. You need to know those. You need to have them memorized, or you need to have them written down on a large piece of paper in front of you so that you can see them. I hope you understand why, but even if you don't, you need to have those things memorized, and if you don't understand, you need to ask about it in class tomorrow so we can clear it up. So with that said, we're going to move on to dealing with higher powers now. So my first example, and I'm just going to jump straight into examples here, I want us to simplify I to the 7th power, right? We might start this problem and say, okay, well, I to the 7th power, I can work with that. That would be I times I times I times I times I times I times I. I think that's 7 of them. Yeah, right on. I have messy handwriting, but we can deal with it. There are 7 I's multiplied together right there. So this is where we start thinking, well, wait a minute. There were a bunch of powers of I we already knew. We knew that I squared was -1. We knew that I cubed was -I. And we know I to the 4th power is 1. And I'm going to be honest with you, this is the super awesome one. Anytime you have 4 i's multiplied together, it's equal to 1. So as you're looking at this I to the 7th, I hope you're looking at it saying, well, wait a minute. The first 4 i's that get multiplied together turn into 1. And then the other 3, I can basically deal with that. I'm looking at I to the 7th here saying, well, wait a minute. This is basically I to the 4th power times I to the 3rd power. And what that means is I to the 7th is 1, because that's what I to the 4th is, times, well, what is I to the 3rd? We know over here that I to the 3rd is -I. This tells us that I to the 7th power is equal to -I. And we're done. We've simplified it. I to the 7th is -I. We win. My next example, I to the 9th power, right? I would argue we can do the exact same thing here, right? And you guys might start by doing I times I times I times I times dot 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 times I. By the way, in math, anytime we put a dot 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 somewhere, it sort of indicates, hey, I'm going to write a bunch more of them there. I'm going to follow the pattern that I'm doing here. I just don't want to have to write it out 9 times. Especially as I get to larger examples, you'll see us use these ellipses to sort of shorten things. And the important thing that we used in the last problem is, we use the fact that I to the 4th is equal to 1. Anytime I can put together 4 i's multiplied together, it's going to be 1. So I'm going to think about this I to the 9th and go, wait a minute, if there are 9 i's multiplied together, let's just think about grouping 4 of them together, and then another 4 of them together. Well, that makes 8. That would mean that there's 1 of them remaining, 1 of them left over. And now I can go through and simplify this. And if you didn't understand that part right there, pause the video and go back. Imagine that you had 9 i's in a row here, right? You have 9 i's in a row here. If we group those together, I could multiply 4 of them together, 4 more of them together, and 1 of them here on the end. Maybe I should put an exponent of 1 here. And the important part is that I to the 9th would then be 1, because that's what the I to the 4th is, times another 1, because that's what I to the 4th is, and finally times I, because that's what I to the 1st power is. This shows me that I to the 9th power will be I. And that's the end of that problem. Okay, I've got one more here that I kind of want you guys to try on your own. I've got I to the 18th power. So think about how you would break that number down. Think about how you could sort of break it into the pieces. Think about how you could use I squared being -1, I cubed being -I, and I to the 4th being +1. So try working through I to the 18th. What I hope you saw here is that if we have I to the 18th, I'm going to have I to the 4th times another I to the 4th times another I to the 4th times another I to the 4th. Oh, and so in total this is 16 factors of I. Well, that means I have 2 of them remaining, so times I squared. And the idea is like, yay, each one of these things is going to turn into 1. This will be 1. This will be 1. This will be 1. And this last one, I squared, that'll be -1. So we'll have 1 times 1 times 1 times 1, that's just 1. 1 times 1 will get me to -1 at the end. Okay? this is how we work with sort of reasonable powers of I. What we're going to look at next is how do we deal with powers of I that are even higher than all of those things. Here we go. I want us to simplify I to the 74th power, right? And right away, many of you may be going like, that number's too big. I don't know what to do with that. And I'd actually like to give a voice to the question that's in your head. Because to me, the question in my head is, man, I'd really like to know how many I to the fourths there are in there. Like, in some sense, I know that this problem is going to be I to the fourth times I to the fourth times I to the fourth times, I don't know how many of them, times I to the fourth times, there will be something left at the end. Like, all of them have been like that. It's been, hey, we have 74 i's in a row. How many I to the fourths are there, and what's left at the end? But think about the question that you sort of just asked yourself. So the question I think you just mentally asked yourself is, how many 4s will there be in 74, and what's left at the end? Right? But mathematically, we can ask that question even better. We can say how many 4s divide into 74, and what's the remainder? Right? And so we're going to make a throwback here to your grade school days of math, right? What is 4 divided into 74? How many times does 4 go into 74? We've got, 4 goes into 7 one time, and then 1 times 4 gives me 4. We subtract. We've got 3, we bring down the 4. And now we're looking at, okay, 4 goes into 34 8 times. Again, 8 times 4 gives me 32. We subtract, and I've got 2. So you've got this idea of like 18 remainder 2 with a little R2 from, whatever grade you learned that in. So what's significant about that thing? What's significant about it is that when we're over here doing I to the fourth times I to the fourth times I to the fourth, blah, 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 I to the fourth, we are going to be doing this. There are going to be 18 factors of I to the fourth. And what will be remaining on the end? What will be remaining on the end is that there will be 2 factors of I left over. What this means is I'm going to have I to the fourth 18 times, and then an I squared on the end. So now, what is I to the fourth? Remember, I to the fourth is 1, so I have 18 1s multiplied to each other, times an I squared on the end, but I squared is -1. And so that means in the end, our I to the 74th can be simplified down to just being -1. And that is the simplification. Okay, so this is a final example that I'd like you guys to try on your own. I'd like us to work out I to the 91st power. Right? And I really want you to have similar work to what I had in the previous problem, right? I sort of want to see you processing through how many I to the fourths are there and what will be left on the end, right? So think through that, try it out. So what we did in the previous problem was we'd sort of set up this framework for our thoughts, and then we said, okay, how many times does 4 go into 91? Well, 4 goes into 9 2 times. 2 times 4 is 8. We subtract and are left with 1. We bring down the other 1. 4 goes into 11 2 times. 2 times 4 is again 8. We subtract, we get 3. And so we have 22 remainder 3. So the big question is, what do these numbers here represent? Right? What does the 22 represent? And what does the 3 represent? Right? The 22 represents that I have 22 factors of I to the fourth. And the remainder of 3 represents that after those 22 factors of I to the fourth, I have I cubed left at the end. Right? In some sense, there will be 88 i's here, that's 22 times 4, and there will be an I cubed left at the end. What we can do from that is we can write this as I to the fourth to the 22nd power. There are 22 factors of I to the fourth, and then there's this lone I cubed on the end. The last thing we can do is we can say, well, I know that I to the fourth is 1, so I have 1 to the 22nd power. I know that I to the third is -I, and so that means that my final answer here simplifies down to being just -I. So I to the 91st power is -I.